All right, so now we're going to look at restricting the domain of a function to make the inverse a function. So we just talked about the horizontal line test and whether or not, how we can use the horizontal line test to determine whether the inverse is a function or not. So what we're going to do right now is graph f of x equals x over 2 quantity squared. And you can either graph this using your parent graph knowledge or you can type it into your calculator. I'm just going to type it into our calculator for right now. So x over 2 quantity squared. We see a nice wide parabola, because remember what would happen, this would be like 1/4, so it's going to be vertically compressed. And our vertex is at 0, 0, so I want to, and we do have our x values that we want, so we're going to have 6.25, 4, 2.25, 1, 0.25, 0, 0.25, and then we're going to see the symmetry, 1, 2.25, 4, and 6.25. We're going to graph that. And so -5 is 6.25. And -4 is 4. -3 is 2.25. -2 is 1. -1 is 0.25. And 0, 0. I start coming up 3, 2.25, 4, 4, and 5, 6.25. All right, so we have that f of x graphed. Then it says use the horizontal line test. Will the inverse be a function? So if I draw a horizontal line, my horizontal line would cross my parabola at 2 spots. So no, the inverse would not be a function. Yes, my original problem is a function, but the inverse using the horizontal line test would not be a function. So now we're going to create the inverse table and then graph the inverse. So these should not be here. All right, those should not be there. So we're going to just switch our x and y. 6.25, -5. 4, -4. 2.25, -3. 1, -2. 0.25, -1. 0, 0. 0.25, 1. 1, 2. 2.25 and 3, 4 and 4, and then 6.25 and 5. We're just going to graph the whole numbers, makes it a little easier. So we'll do -4, -4. We'll do the 6.25. 6.25 is -5. So we'll approximate. 2.25, -3. 1, -2. 0.25, -1. 0, 0. 0.25, +1. 1, 2. 2.25, 3. 4, 4. And 6.25 and 5. So it says, does the inverse pass the vertical line test? Nope. If I draw a vertical line, the inverse is not a function like we predicted. So now we're going to use the algebraic way or the word way to find the inverse. I'm going to use the algebraic way. So I'd have x equals y divided by 2 all squared. And I would take the square root of both sides, giving me y divided by 2 equals plus or minus the square root of x. Don't forget that plus or minus since we wrote the square root. And last thing, I would multiply by 2. So my final inverse would be f inverse of x equals plus or minus 2 times the square root of x. So now what we're going to do is we're going to use color or trace over the portion of the graph of y equals x over 2 squared for which x is greater than or equal to 0. So I'm going to use a highlighter here. And remember, look at the parabola here. We're looking for where the parabola has x values that are equal to 0 or greater. So everything on this side, the x is equal to 0 or greater than 0. And then we're going to use another color to trace only the inverse part of that. So if we think of our line of symmetry going right here at y equals x, the part that folds over it is the top half part of our sleeping parabola. So this part of our inverse is what goes along with the yellow part of our original problem. So now it says, is the inverse of this part of y equals x over 2 squared a function? So if I didn't have this bottom part and only had the orange, would that pass the vertical line test? Well, yes, because there's no bottom part, so it would pass the vertical line test. And so if I got rid of this part, that's basically what we're saying. If I got rid of that part, it would pass the vertical line test. So then it says, what would be the equation for the inverse of f of x equals x over 2 quantity squared? So we're going to say the inverse function. That's the key word, the inverse function. So if we want the inverse to be a function, we'd have to say f of x equals f inverse of x. And it's just the top half. Because remember, we have that plus or minus. So it's just the plus part. So it'd be the square root of x to square root of x. Not plus or minus anymore, just the plus part. So f inverse of x equals 2 times the square root of x. We also, though, have to go back and add to this equation. So the only way we can get the top part of this is to get only the right side of our original function. So what we do is we do what's called restricting the domain. So we just add to our inverse where x is greater than or equal to 0. So the only way we can get half of our parabola, the yellow part, is by adding this little statement where x is greater than or equal to 0. We want every x value that's equal to 0 or greater than. So that's what we call restricting the domain. And we do that if we wanted the inverse to be a function, because now we have just the top half of the sleeping parabola, meaning it is a function. All right, we'll do one more example. It says consider the function g of x equals x minus 3 squared. It says how can you restrict the domain of g of x so its inverse would be a function? So if you're not sure, first thing we would do is we can just graph x minus 3 squared. So x minus 3 squared is moved to the right 3, and it's our normal parabola. So we go right 1 and up 1 from that vertex, left 1 up 1, right 2 and up 4, left 2 and up 4. And remember, right now this would fail the horizontal line test. So for us to pass the horizontal line test, we want to get rid of half of it. So if I get rid of half of it and start it at the vertex and go to the right, I would be saying my equation is g of x equals x minus 3 quantity squared, but I'm starting it right here, which is at 3. So I'm saying where my x values are greater than or equal to 3. And so now, if I find the inverse of this, my inverse would be a function. Again, the whole thing we're talking about is that they want to be functions. So now it says graph g of x with its restricted domain, and then graph its inverse. Okay, so we already graphed the g of x with just restricted domain. Now we're going to graph the inverse. So if I'll call that g of x, if I have 3, 0 here, my inverse would be 0, 3. If I have 4, 1, my inverse will be 1, 4. And this is 5, 4, so it would be 4, 5. I call that g inverse of x. Again, the inverse would now pass the vertical line test. All right, last thing it says find the equation of the inverse of g of x, which is with its restricted domain. So I switch my x and my y. So I have x equals y minus 3 squared. First thing I would do is take the square root. And now, again, normally when we would take the square root, I'd write plus or minus, but since I only have the top part, I'm not going to do plus or minus. I'm just writing the positive part. And then I'd add 3 at the end. So my inverse, my g inverse of x, that is a function, would be the positive square root of x plus 3. And that's our parent graph for square root of x and plus 3. All right, on the next page, there is an example for the parabola, which we kind of did. But we can also see, if we look at examples 2 and 3 here, there's also examples if we start with a radical, how we would have to restrict the domain on the actual inverse. So if I were to graph my original problem, which is square root of x, remember square root of x is starting at 0, 0, and then 1, 1, and then we do square root of 4 is 2, 4, 2, and then 9, 3. So that's f of x. The inverse would look like this. 0, 0. Well, the reverse of 0, 0 is still 0, 0. Reverse of 1, 1 is still 1, 1. The reverse of 4, 2 is 2, 4. And the reverse of 9, 3 is 3, 9. So this is what we get. That would be my inverse. Now, I want to change my f of x to y. And then I'm going to switch my x and my y, and solve for y. So I'd have to square both sides. And so I'd end up with f inverse of x equals x squared. Well, remember, x squared is a parabola, and this isn't a full parabola. It looks like half of a parabola. And the parabola's vertex would be at 0, and it's every x value to the right of that. So guess what? We have to restrict the domain actually to the inverse here. So I'd say, all right, my inverse would be y f of inverse of x equals x squared, but it's starting at x, and it's every x value greater than 0. So where x is greater than or equal to 0 is my true inverse for that. All right, one more. All right, if I have the square root of x minus 2 plus 3, this would be our parent graph for the square root where we're going right 2 and up 3. And then our normal pattern goes right 1 and up 1. Square root of 1 is 1, and square root of 4 is 2. And the next one wouldn't fit, so we'll just do 3 points here. So that's y. Our inverse, so again, we have 2, 3, so our inverse would be 3, 2. Here's 3, 4, so it would be 4, 3. And then we have 6, 5, so it would be 5, 6. So there's my inverse. As I go and switch my x and y to get my inverse equation, I'm doing PEMDAS backwards to get the y by itself, so we'd subtract 3. To get rid of the square root, I have to square. Just be careful you're squaring that entire side. So we'd have y minus 2 equals x minus 3 quantity squared, and then I would add 2 at the end. So my equation would be y inverse equals x minus 3 quantity squared plus 2. Now, I'm almost done, but not quite, because, again, this would give me a full parabola, but my inverse is not a full parabola. My inverse starts here, and it's every x value greater than that. So I have to write that little domain restriction, or that little note at the end, where it's starting at an x value of 3, and it's every x value greater than that. So I add where x is greater than or equal to 3. All right, that's it.